Welcome, physicists. So this is the prac that I want you to do from home. Not the actual prac, I'll do the demonstration today, but you'll be doing this right up today. So the prac is called the magnetic field in a Slinky. So what we have here, our setup, is a Slinky, a metal Slinky here, is connected to an ammeter, so you'll be able to see it. You'll be able to see the current. What we're going to be doing is passing an electric current through this Slinky, through the metal Slinky. Now the current is going to get quite high, so I've got a little switch here, so the current will only run when I push the switch down. That's a safety thing, because as I mentioned, the current will be quite high. We'll be going up to 2 amps, which will give you a nasty little shock. What we're going to be doing is measuring the magnetic field through the Slinky. So this thing is a magnetic field sensor, and we're going to be detecting how much magnetic field is passing through it. So a couple of bits of background information. Electricity and magnetism are very, very closely linked. This is something we're going to do a lot of in the rest of Unit 3. Rest of Unit 3. Electricity and magnetism, they're basically two sides of the same coin. That's why we have electromagnetic radiation, right? Electromagnetic. So we can prove this in a few different ways, but what we're looking at today is creating a current running through a wire will actually create a magnetic field. And that's what we're going to be looking at. So on the board here, our magnetic field sensor output is here. So it's currently at a very, very small amount. Now, magnetic field is measured in Tesla. So Nikola Tesla has something named after him. It's the magnetic field strength. Not just, well, he's got the cars named after him, but this is way more important. So it's currently reading a very small amount of magnetic field. Now, it should be zero because we have no current running through here, but the Earth has a magnetic field. There is a power point here, and I mentioned electricity will generate magnetic fields. The magnetic field sensor is attached to this little reader here, which will also generate a magnetic field. My laptop will generate a magnetic field. So it is generating a small amount of magnetic field already. So what we're going to be doing, well, actually, before I even do that, let's just a quick unmeasured demonstration. So when I start passing a current through here, so we've got about a 1.27 current, you'll see the magnetic field jumps up as soon as I'm pushing the switch down. So if we let go of that, it drops back down to what it was. So we can see there's definitely a magnetic field being created by the current passing through. All right, so if you have a look at your table, what we're going to be doing is running a few different currents through this solenoid. Now, I should mention, a solenoid, a Slinky here is acting like a solenoid. A solenoid is just a really coiled wire. We're going to be using those quite a bit in this unit. But yeah, a solenoid is basically a really long wire that's coiled up. Okay, and we'll see those later on. So our Slinky is our solenoid in this case. We're going to be running a few different currents through it. Now, the length of the solenoid, now these, in your data table here, you'll need to put a couple of things down the bottom. So the length, I've tried to make this as easy as possible, and I've got the length to be exactly 1 meter. I've got a 1 meter ruler behind the solenoid, so you can see it's exactly 1 meter. And the number of turns, I've, again, tried to make this as easy as possible, and I've counted out 100 turns. So our solenoid has 100 turns in 1 meter, so hopefully you can figure out the turns per meter. So when it comes time to calculating turns per meter, you just divide the number of turns by the number of meters. Okay? So in this case, 100 turns divided by 1 meter, so it's 100 turns per meter. But that'll become important in part 2. Okay, so at the moment we're just going to be doing part 1, where we adjust the current to different amounts, and we'll see that effect on the magnetic field. All right? So first thing we want to do, we have zero current, so what I'm going to do is zero the magnetic field. Okay, so, yep, there's our 0 point. So it's gone right down. Now, the way this software works is we're going to collect data for about 10 seconds, and then from that 10 seconds, we're going to create a minimum, a maximum, and an average value that it reads over that 10 seconds. I'm going to put those up on the board here. Your minimum and your maximum are going to be your error bars. Okay, so the minimum will be your lower error bar, your maximum will be your upper, and the average will be your point on your graph. Okay, so once we've done this, you'll need to graph it. You'll need to read through the prac sheet to see the sort of analysis that you need to do. But I might come to that a little bit more in the part B video. I'm going to split this up into 2 videos. Okay, so this is the part A one. So first up, we'll collect some data. So we'll collect for about 10 seconds. Okay, and so if we have a look at our statistics, now I don't think you can read these from on the I don't think you can read these on the screen, but you'll have to take my word for it. So at a current of 0 amps, we have a minimum of negative 0.001, we'll call it 0.001, a maximum of 0.004, and an average of 0.001. Okay? So the negative, we can't actually have a negative magnetic field. The negative just means basically we've zeroed it slightly off. Okay, so it's always going to be fluctuating a little bit. So where our 0 point is, it's just dropped a little bit below that, which is okay. Now, I didn't mention, the symbol for magnetic field is B. Obviously, the symbol for current is I. Why not have B as the symbol for magnetic field? Okay, so we've already got our first data point at 0. We've got a very, very small magnetic field. So let's have a look. Our next data point is at 0.5 amps. So I'm going to push the switch down and adjust our current here to 0.5. Okay, so there we are. It's changed a bit now. I'm hoping you can see this on the video. It's currently 0.49. There we are, 0.5. It will move around a little bit, but that should be okay. All right, so let's collect some data for that point. All right, so at 0.5 amps, we have a minimum of 0.060. We have a maximum of 0.067. And we have an average, oh, sorry, that's not right, 0.070. Sorry, we're rounding up, 0.697, so 70. And our average is 0.063. Just double check that. Yep, that's all right. Okay, so there we go. We've got our average, our minimum, and our maximum. So then we've got our 0.5 amp reading. Do the same for 1 amp. Okay, so this one, I will turn up our current to 1 amp. Which I'll do that so you can see it. Moving around a little bit. Oh, look, it's going to be close enough. The very small amount of variation isn't going to change it too much. So we'll just go from there. Collect, and this is our 1 amp value. Okay, so at 1 amp, we have a minimum of 0.123. We have a maximum of 0.129. And an average of... Oh no, sorry, that was the average. 0.133 is our max. 0.129 is our average. Yep, that's right. Now, I should mention, these readings are in millitesla. You can see down the bottom, MT, millitesla, so these are thousands of Teslas. So in your table, it's already in millitesla. So yeah, we're fine there. Okay, next measurement. So we've got 1, we'll do 1.5, and I'll put 2 up next. Okay, so we'll change this to 1.5. Okay, there's 1.5. We'll get some data. Okay. So next, we have a minimum of 0.199. We have a maximum of 0.210 and an average of 0.204. Alright, so there's our 1.5 values. We'll try again with our 2 amp values. I'm not sure if you can hear it on the video, but once you get up to 2 amps, this thing starts humming. It's very concerning. If I accidentally touch it, at least it'll be recorded on video what I've done. Okay, so there's 2 amps. Definitely not touching it. Okay, so that's our data. So our minimum at 2 amps is 0.259. Our maximum, 0.273. And our average of 0.266. Make sure that's right. 266. Yep. Okay. So there is our data for Part A. So our Part A prac has been completed. I'm going to stop this video in a moment and we'll just do Part B. But in terms of your Part A analysis, you'll need to draw a graph for this and determine an equation for line of best fit. So the analysis, you should be able to see Part 1 on your prac sheet. Yeah, just follow that through. Okay, so I'll stop this video now and then we'll do the Part B prac.